I'm Anil Kumar, sharing with you a video on limits. In this particular video, I'm going to highlight that limits may exist or may not exist when we are approaching a value. Perfect. And these are a few good examples to consider. We have many more. You can always type in Anil Kumar limits playlist to see some examples. The first one here is limit x approaches 0 for 1 over x. Then we have limit x approaches 3, square root of x minus 3. Limit x approaches minus 1 for x square minus 1 divided by x plus 1 whole square. Then we have limit x approaches 1, x minus 1 divided by absolute value of x minus 1. Now in the first case, if I substitute 0, what do I get? I get 1 over 0, right? So in this case, I get 1 over 0, and that is not defined, right? You cannot do it. So we say does not exist. Do you see that? You can also see from the graph. If I sketch the graph of 1 over x, what you see is kind of like this, right? It's kind of like this. That is a vertical asymptote. So as you approach 0 from both left side or from the right side, you approach vertical asymptote, not a defined number, and therefore this limit does not exist. Perfect. Now here, limit when x approaches 3. Well, some of you can always place 3 here, and you can write this limit as 0. However, that will be a wrong answer. Why? Let's look into this also. Now, sketch this function. Square root function translated 3 units to the right. Okay, so this is your 3. If you approach from the right side, so what is the limit? When x approaches 3 from the right side for square root of x minus 3. If you approach from the right side, you are approaching 0. That is right. How about the limit when x approaches 3 from the left side when you approach from the left side? Now the domain is restricted. X is only greater than or equal to 3. You cannot approach from this side for x minus 3. Is it okay? And therefore it does not exist. These two limits should be equal if the limit exists. I hope you understand the concept, and the figure is self-explanatory. Let's do this one. Here we have limit x approaches minus 1, x square minus 1 over x plus 1 whole square. We do have a common factor, so if I factor x approaches minus 1, we get x plus 1 times x minus 1 in the numerator. Denominator will be x plus 1 whole square. One of them cancel out, right? So we have a limit x approaches minus 1, and we get x minus 1 over x plus 1. Now if I substitute minus 1 here, I get something over 0. Do you see that? Minus 2 over 0. So I get minus 2 over 0, right? That is undefined, and therefore the limit does not exist. At minus 1, there is still a vertical asymptote, as in this case. Do you agree with me? So that is the reason why it does not exist. Now for the absolute functions, whenever you are working with absolute functions, you have to write absolute function as a piecewise function. So absolute value of x minus 1 could be written as x minus 1 for x greater than or equal to 1, right? And minus of x minus 1 for x less than 1. Therefore, this function should be solved from both left side and right side. So what we will do here is that we will find the limit when x approaches 1 from the left side for x minus 1 over absolute value of x minus 1, and also limit when x approaches 1 from the right side for x minus 1 over absolute value of x minus 1. Correct? If you approach from the left side, it is minus of x minus 1, right? So this could be written as limit x approaches 1 from the left side, x minus 1 over minus of x minus 1, and that gives you minus 1. On the other side, it is plus, right? X approaches 1 from the positive side. We get x minus 1 over x minus 1, which is equal to 1. And you can see both the limits are not equal, right? So they are not equal, and therefore the limit does not exist. Perfect. I would like you to sketch this graph and then show, as we've done for others, why is it so, right? So x minus 1, you know, if you sketch the graph, then at 1 you get positive value and the negative value if you approach from left and right side, correct? That's the graph. There's a jump discontinuity. The value approach from both the sides is different, and therefore the limit does not exist, right? So these are a few examples where the limit may not exist, right? And in these set of videos, we have also seen how to find limit of functions from their graph, from piecewise functions, by direct substitution, by change of variable, rationalization, and many techniques. I'm Anil Kumar, and I hope that must have helped you a lot. Feel free to post questions and subscribe to my videos. Thank you, and all the best.